Next question. Let A of alpha is equal to cos alpha minus sin alpha, cos alpha. Find A of alpha plus beta. Here it is given A of alpha is equal to this one. Okay. So what is A of alpha plus beta? Replace alpha to alpha plus beta. That's all. So A of alpha plus beta is equal to cos alpha plus beta. In place of we should write alpha plus beta. Alpha. In place of alpha, we should write alpha plus beta. Okay. So cos alpha plus beta minus sin alpha plus beta. Here sin alpha plus beta cos alpha plus beta. Okay. We have got A of alpha plus beta. Now come to second question. Find A of alpha into A of beta. So before we need to find A of alpha into A of beta, we need to find A of beta. A of beta is cos beta, right? In place of alpha, we should write beta, cos beta. So minus sin beta, cos beta. Okay. Then here we have got A of beta. Then let's find A of alpha into A of beta. Product of these two matrices. That is A of alpha into A of beta is equal to A of alpha is nothing but cos alpha minus sin alpha, cos alpha into matrix cos beta minus sin beta cos beta. Okay. Now let us multiply these two matrices. Here first row multiply with first column. Okay. Multiplying these two matrices, the method is first row multiply with the first column, that is cos alpha into cos beta plus minus sin alpha into sin beta, that is minus sin alpha sin beta. Okay. Then first row multiply with the second column. So cos alpha into minus sin beta, that is minus cos alpha sin beta. Then first row with the second column. Okay. So minus sin alpha cos beta minus sin alpha cos beta. Now come to second row. Second row multiply with the first column. So sin alpha cos beta cos alpha plus cos alpha sin beta Okay. Then second row multiply with the second column. Sin alpha into minus sin beta, that is minus sin alpha sin beta plus cos alpha cos beta Okay, don't be confused. First row multiply with the first column, first row multiply with the second column. Okay. Then in second row multiply with the first column, second row multiply with the second column. Okay. So here, now what is cos alpha cos beta minus sin alpha sin beta? We have already learnt in trigonometric functions, trigonometric identities, right? So cos alpha cos beta minus sin alpha sin beta is nothing but cos alpha plus beta. Okay, cos alpha plus beta. And here if we take minus outside, so sin alpha sin beta plus cos alpha, sin alpha cos beta plus cos alpha sin beta, that is sin alpha plus beta. Okay, minus is there, so minus sin alpha plus beta. Okay. Next here, see, it is also sin alpha cos beta plus cos alpha sin beta, that is sin alpha plus beta. Sin alpha plus beta. And here, see, cos alpha cos beta minus sin alpha sin beta, that is nothing but cos alpha plus beta. Okay, cos alpha plus beta. Alpha plus beta. Okay, so we have got a of alpha into a of beta is equal to matrix cos alpha plus beta minus sin alpha plus beta, sin alpha plus beta, cos alpha plus beta. Our third question is a of alpha into a of beta equal a of alpha plus beta? See, what is our a of alpha plus beta? Cos alpha plus beta minus sin alpha plus beta, sin alpha plus beta, cos alpha plus beta. That is equal to a of, see here, the same we have got a of alpha into a of beta, right? A of beta. A of beta also matrix cos alpha plus beta minus sin alpha plus beta, sin alpha plus beta, cos alpha plus beta. Okay. So this answer, yes. Yes, a of alpha plus beta is equal to a of alpha into a of beta. Next question, what is a of alpha square? So let us find a of alpha whole square. A of alpha whole square is equal to a of alpha into a of alpha. That is equal to a of alpha is cos alpha minus sin alpha, sin alpha, cos alpha into same matrix cos alpha minus sin alpha, sin alpha, cos alpha. Okay, now let us multiply these two matrices. First row with first column cos alpha into cos alpha, cos square alpha, okay, plus minus sin alpha into sin alpha minus sin square alpha, minus sin square alpha. Next, first row multiply with the second column. So cos alpha into minus sin alpha cos alpha, okay, minus sin alpha plus minus sin alpha into cos alpha. So minus sin alpha into cos alpha. Then next, second row multiply with the first column. So sin alpha into cos alpha, sin alpha into cos alpha plus cos alpha into sin alpha plus cos alpha into sin alpha. Okay. Next, second row with multiply with second column sin alpha into minus sin alpha minus sin square alpha, cos alpha into cos alpha plus cos square alpha. Okay. So here, so what is this one? See, cos square alpha minus sin square alpha, by trigonometric identities, cos square alpha minus sin square alpha is nothing but cos 2 alpha. Okay, cos 2 alpha. And here take minus outside. Here you will get sin alpha cos alpha plus sin alpha cos alpha. That is 2 sin alpha cos alpha. 2 sin alpha cos alpha is nothing but sin 2 alpha. Okay, that is we have applied many times, right? Sin 2 sin theta cos theta, that is equal to sin 2 theta. So here also take minus outside, so you will get minus of 2 sin alpha cos alpha. 2 sin alpha cos alpha is sin 2 alpha. Sin 2 alpha. Okay. So here sin alpha same as this one. Sin alpha cos alpha plus cos alpha sin alpha, no minus. Okay. Sin alpha cos alpha plus cos alpha sin alpha is nothing but 2 sin alpha cos alpha, that is sin 2 alpha. Sin 2 alpha. Here cos square alpha minus sin square alpha, that is cos 2 alpha. So it is a of alpha whole square. Next example is, if A is a square matrix such that A square is equal to A, then I plus A whole square minus 3A is equal to options A, I minus A, I, 3. See, what is I? I is an identity matrix. See, identity matrix of order 2 is 1, 0, 0, 1. And identity matrix of order 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. Diagonal, all the diagonal elements are 1. Okay. Now let us simplify this one to get the answer. I plus A whole square minus 3a, that is equal to, see here I plus a whole square, it is in the form of a plus b whole square, right? Let us expand it. I plus a whole square, a plus b whole square, that is a square plus b square plus 2ab, right? So I square plus 2 into a into I plus a square minus 3, right? Then what is I square? See, we know that I is an identity matrix, right? See, I square is nothing but I itself. Okay, see, if you want, you can check it. Take a 2 by 2 matrix, identity matrix, 1 0 0 1 and 1 0 0 1. Then multiply, you will get the matrix 1 0 0 1. So remember I square. Okay, see, you just take an example here, numbers. Okay, we know that 1 square. See, 1 is a multiplicative identity of numbers, right? Here, identity matrix is the multiplicative identity of matrix. Okay, so therefore I square, identity, square of an identity matrix is identity matrix itself. Okay, so 1 square is equal to 1 itself. In the same way, I square is equal to I itself. Okay, so here I plus 2 into a into I. Okay, so here also, what is a into I? A into I. Now let us take numbers. See, we know that 6 into 1 is equal to 6 itself, right? See, here 1 is a multiplicative identity of numbers, right? Here we know that identity matrix is the multiplicative identity of matrix, right? So here also ai is equal to a itself. That also you can check. Take one matrix, okay, 3 2 5 0 into 1 0 0 1. You will get same matrix 3 2 5 0. Okay, so remember a into any matrix into I, that is equal to a itself. Okay, so here 2 into a. Okay, ai is equal to a. Then a square, it is given that a square is equal to a. In question it is given a square is equal to a minus 3a. That is I plus here 2a plus 3, 2a plus a, 3a, 3a minus 3a, 0. Right? 3a minus 3a, that is a 0 matrix. Okay. So 0 matrix, that is equal to I plus a 0 matrix, I itself. Okay. So I. So I is the answer. A manufacturer produces 3 products X, Y and Z which he sells in 2 markets. Annual sales are indicated below. Market first and second. Market 1, market 2. Products. Okay, here number of X 10,000. That means he sells a number of X means 10,000. X 10,000 X products in market 1 and he sells 2,000 Y products in market 1. And he sells 18,000 Z products in market 1. Similarly, 6,000 here number of X products 6,000, number of Y products 20,000, number of Z products 8,000. And it is also given he sells X product for rupees 2.50 per unit. Okay, and Y products for 1.50 and Z product for 1.0. Okay, for rupees 1. So here find the total revenue in each market with the help of matrix algebra. Okay, so here let us write this information in matrix form. The quantity of the products matrix is matrix A. Okay, let the quantity matrix A is equal to 10,000, 2,000, 18,000, 6,000, 20,000, 8,000. Okay, and sale price. Let sale price matrix B is equal to 2.50, 1.50 rupees 1. Okay. Then it is sale price matrix, that is it is for X, product X, unit price of product X, unit price of product Y, unit price of product Z. So here it is also, it is market 1, market 2 and X, Y, Z. Okay, number of products. Now, how to find the total revenue? That is nothing but multiplication. Okay, we know that 10,000 into 2.50, okay, plus 2,000 into 1.50 in market 1. Okay, first we will find the total revenue. See, we have to find the total revenue in each market, right? So first we will find the total revenue in market 1. Okay, that is 10,000. Okay, there are total 10,000 X products and 2,000 Y products to 18,000 Z products sales in market 1. Okay, market 1, market 2. Okay, so here now let us, first of all let us find total revenue in market 1. Okay, that is 10,000 into 2.50, 10,000 into 2.50 plus 2,000 into 1.50, 2,000 into 1.50 plus 18,000 into 1, 18,000 into 1. Okay, then next step, we will find the total revenue in market 2. Okay, 6,000 into 2.50 plus 20,000 into 1.50 plus 8,000 plus 8,000 into 1. So total 46,000, 53,000. So 46,000, the total revenue in market 1 is 46,000 and total revenue in market 2 is 53,000. Actually, here we did the multiplication of these two matrices. If A is equal to matrix 2 minus 1 3 4 1 0, B is equal to matrix minus 1 3 5 0 2 minus 2, C is equal to matrix 3 1 minus 2 2 0 5, then show that A plus B into C is equal to AC plus BC. To prove this one, first of all let us find the LHS part, then RHS and verify. Okay, so here to find A plus B into C, we need to find A plus B, right? A plus B, addition of these two matrices, 2 minus 1 3 4 1 0 plus minus 1 3 5 0 2 minus 2. To add two matrices, we have to add corresponding elements, that is 2 plus minus 1 is 1, minus 1 plus 3 2, 3 plus 5 8, 4 plus 0 4, 1 plus 2 3, 0 plus minus 2 minus 2. Now we have got A plus B and next we have to find A plus B into C. A plus B into C, that is A plus B is matrix 1 2 8 4 3 minus 2 into C. C is 2 by 3 matrix, 3 1 minus 2 2 0 5. Okay, here two matrices can be multiplied. See, because here number of columns 2 and number of rows is 2. Okay, that is equal to, now we can multiply first row, multiply with the first column, that is 1 into 3 3 plus 2 into 2 4. Next, first row multiply with the second column, 1 into 1 1 plus 2 into 0 0. Next, first row multiply with the third column, 1 into minus 2 plus 2 into 5 plus 10. Then second row multiply with the first column, 8 into 3 24 plus 4 into 2 8. Then Second row multiply with the second column. 8 into 1, 8 plus 4 into 0, 0. Second row multiply with the third column. 8 into minus 2, minus 16 plus 4 into 5, 20. Then third row multiply with the first column. 3 into 3, 9 plus minus 2 into 2, minus 4. 3 into 1, 3 plus minus 2 into 0, 0. Third row multiply with the third column. 3 into minus 2, minus 6 plus minus 2 into 5, minus 10. Minus 10. That is equal to 3 plus 4, 7, 1, 8, 32, 8, 4, 9 minus 4, 5, 3, minus 16. So, we have found our LHS part, right? That is A plus B into C. We have got LHS part. Next, let us find RHS. For that, we need to find AC and BC. Now, we need to find AC. A into C. A is 2, minus 1, 3, 4, 1, 0 into C. C is 2 by 3 matrix. 3, 1, minus 2, 2, 0, 5. Okay. A is 3 by 2 and B is 2 by 3 matrix. So, it can be multiplied. That is equal to first row multiply with the first column. 2 into 3, 6 plus minus 1 into 2, minus 2. First row multiply with the second column. 2 into 1, 2 minus 0. First row multiply with the third column. 2 into minus 2, minus 4, minus 1 into 5, minus 5. Next, come to second row. Second row multiply with the first column. 3 into 3, 9 plus 4 into 2, 8. Okay. Second row multiply with the second column. 3 into 1, 3 plus 4 into 0, 0. Second row multiply with the third column. 3 into minus 2, minus 6 plus 20. Then third column multiply third column with the third row. Okay. Third row multiply with the first column. 1 into 3, 3 plus 0. Third row multiply with the second column. 1 into 1 plus 0 into 0, 0. Okay. Third row multiply with the third column. 1 into minus 2 plus 0. That is equal to 6 minus 2, 4. 2 minus 0 is 2, minus 9, 17, 3, 14, 3, 1, minus 2. Okay. Now we have got AC, A into C. Next we need to find BC. Okay. B into C. What is B? B is minus 1, 3, 5, 0, 2, minus 2 into C 3, 1, minus 2, 2, 0, 5. Okay. Now let us multiply these two matrices. First row multiply with the first column. So minus 1 into 3, minus 3 plus 3 into 2, 6. First row multiply with the second column. Minus 1 into 1, minus 1 plus 3 into 0, 0. First row multiply with the third column. So minus 1 into minus 2, 2 plus 3 into 5, 15. Next, second row multiply with the first column. 5 into 3, 15 plus 0. Second row multiply with the second column. 5 into 1, 5 plus 0. Okay. Second row multiply with the third column. 5 into minus 2, minus 10 plus 0. Third row multiplied with the first column. 2 into 3, 6. Minus 2 into 2, minus 4. Third column multiplied with the second column. Third row multiplied with the second column. 2 into 2 plus 0. Okay. Third column multiplied with the third column. 2 into minus 2 minus 4. Minus 2 into 5 minus 10. That is equal to, that is BC is equal to minus 3 plus 6, 3, minus 1, 17, 15, 5, minus 10, 2, 2, minus 14. Okay. Now we have got B into C. Now we need to find AC plus BC, right? Now add these two matrices AC and BC. See, AC is this one, BC is this one. So 4 plus 3, adding corresponding elements, 4 plus 3, that is 7. Okay. 2 minus 1, that is 1. Minus 9 plus 17, 8. 17 plus 15, 32. 3 plus 5, 8. 14 minus 10, 4. Okay. 3 plus 2, 5. 1 plus 2, 3. Minus 2, minus 14, minus 16. So we have got AC plus BC, that is equal to A plus B into C. Consider the following statement. P of n is equal to A raised to n, that is equal to matrix 1 plus 2n minus 4n, n 1 minus 2n for all n belongs to n. Write P of 1. Before that, note that A raised to m into n, that is integral powers of matrices. A raised to m into n is equal to, A raised to m plus n is equal to A raised to m into A raised to n. And A raised to m whole raised to n, that is equal to A raised to m into n. Okay, now here let us find P of 1. To find P of 1, we have to substitute n is equal to 1 in P of n, that is A raised to n. Okay, so P of 1 is equal to 1 plus 2 into 1 minus 4 into 1, 1 minus 2 into 1. That is substituting n is equal to 1 in P of n to get P of 1. Okay. That is equal to 1 plus 2, 3 minus 4, 1 minus 1. 1 minus 2 minus 1. Okay. Now we have got P of 1. Second question, if P of k is true, then show that P of k plus 1 is also true. So if P of k is true means replace n to k in P of n. Okay. P of k is true means P of k is equal to, that is A raised to k is equal to 1 plus 2k minus 4k. Substitute n is equal to k. K 1 minus 2k. Okay. Then next we have to find P of k plus 1. To show P of k plus 1 is true, we have to find P of k plus 1. Okay. P of k plus 1 is equal to, what is P of k plus 1? P of n is A raised to n. So P of k plus 1 is A raised to k plus 1. That is A raised to m plus n is equal to A raised to m into A raised to n. Similarly, A raised to k plus 1 is equal to A raised to k into A raised to 1. What is A raised to k? 1 plus 2k minus 4k, k 1 minus 2k into A raised to 1, this one, 3 minus 4, 1 minus 1. Okay. Now let us multiply these two matrices. Okay. That is equal to, first row multiply with the first column, 1 plus 2k into 3. So 3 into 1 plus 2k minus 4k into 1 minus 4k. First row multiply with the second column, minus 4 into 1 plus 2k plus 4k Second row multiply with the first column. 3k plus 1 minus 2k. Second row multiply with the second column. K into minus 4 minus 4k minus of 1 minus 2k. That is equal to, here expand this one, simplify. 3 into 1 plus 2k, that is 3 plus 6k minus 4k. So 3 plus 2k. Minus 4 into 1 plus 2k, that is minus 4 minus 8k plus 4k, that is minus 4 minus 4k. Here 3k minus 2k is k plus 1. Here minus 4k, multiply minus to each of the terms in the bracket. Minus 1 minus 2k plus 2k. So minus 4k plus 2k minus 2k minus 1. So minus 1 minus 2k. Okay. Now to show p of k plus 1 is true, we have to make it in the form of this p of n. Okay. In this form we have to make it. So here, see, 3 plus 2k, we have to write in the form of this one, 1 plus 2n. Okay. That is 1 plus, we can write it as 1 plus 2 into k plus 1. See, after expanding, after simplifying, you will get the same thing. 1 plus 2k plus 2, that is 3 plus 2k. So, next one, take minus 4 outside. So, you will get minus 4 into 1 plus k. That is k plus 1. Or you can write k plus 1. K plus 1. Then, next, k plus 1 itself. Minus 1 minus 2k. We have to make it in the form minus 1 minus 2n, right? 1 minus, so let us write 1 minus 2 into k plus 1. See, after simplifying, what we will get? 1 minus 2k minus 2k minus 2. That is 1 minus 2 is minus 1 and minus 2k. Same, right? So now we have got it in the form of this one, p of n. Therefore it is p of k plus 1. So p of k plus 1 is also true when p of k is true. That's all.